So hello, and welcome back to CS492G, Foundations and Future of Virtual Reality, Artificial Intelligence, and Massively Multi-User Online Role-Playing Games. Today, we continue with the second part about artificial intelligence. Last time we learned about history and about philosophy. And today we continue with our non-technological, non-scientific aspects of artificial intelligence beyond the mainstream. Namely, today we learn and talk about pedagogy of artificial and non-artificial intelligence. So a talk which will be conveyed by Jihoon. So welcome. And again, please everybody try to turn on your camera, and thank you for agreeing to be recorded. So that being said, now I shut myself up and pass on the word and microphone to Jihoon.
Thank you, Professor. Do you see my PPT well? Oh, let me turn it. Okay, so let me start. So today I will talk about the pedagogy of intelligence, and my name is Jihoon So. And this is the contents of today. So we will talk about four aspects. And the first aspect is how can we quantify the intelligence? And the second is the requirement of intelligence level to be taught. And the third aspect is about compare teaching and training. It's about teaching the human and training the AI. And the last aspect is what makes ethics. So let's move on to the first chapter. So there's a lot of quantified tests about the intelligence, such as the IQ test or EQ test. And maybe all you guys are heard about IQ test. The most famous test is IQ test. So the aim of this test is to quantify the portion of intelligence with a standard score. So many people think that IQ is really good test. The IQ is the absolute test, but it's not really. The test is only for the fraction of our intelligence. It is about like calculating or about the mathematics or like that. So one of other thing that we can think about is EQ. EQ is the test for the emotional intelligence quotient. So the EQ test verifies the emotional identification and control or motivation or interpersonal skills. So for the IQ test, lots of animals get a good scores. The animals are often compared to the standards too. So for example, octopus and killer whales or get the high score in IQ tests like the 80 or above. Well, that doesn't mean they can communicate for the humans. So high test score does not mean they have interaction with the human. This problem will be addressed in chapter 2. So there is also the test for the AI, the Turing test. The Turing test is to distinguish between the humans and AI. So AI can be evaluated depending on how much Turing test has passed. So prepare on questionnaire and 2 respondents. So one of the respondents are the human and one other is the computer. The questionnaire doesn't know which is computer or human. If the response is only on the keyboard and the questionnaire cannot determine which is computer or which is human, then the computer passed the test. In the other word, if the computer can communicate with like a human being, then we can think the computer is really like the human. So this is the most basic Turing test. And there was an artificial intelligence that cut 2 to 3 out of 10 people, but there was only few AI that passed this test. One of the AI that passed the test is Jihoon from the England at 2014, I think. A really famous Turing test is the CAPTCHA that you really well see on any website. So this is the CAPTCHA that you may experience it before. This type of simple Turing test has already been too old that almost of tests are passing by the AI companies like Google or other companies. But well, this is a very simple example of Turing test. Actually, it's the reverse Turing test, but well, this is the Turing test. So yeah, that was the first chapter. And let's move on to the second chapter, the target of pedagogy. So the previous chapter, I said that there's some animals that get a high score in the IQ test, like octopus or the killer whale. But about the 35 of people get IQ lower than the 90, but some animals get the higher score than the 90. So the IQ test not always mean that animals are enough to get or communicate or some thought. So to teach or talk to get each other, they need a cognitive system. The sort of cognitive system or requires at least 3 things, 3 aspects. The first, learner must understand the teacher's cognitive intent. So the learner try to learn which mean. And the second, the teacher and learner must be able to understand their referential signals, which is the pointing some things or the eye gazing for something. And the last one, the learner must be able to understand the informational contents of the pedagogical interaction. It can be the language, it can be, well, the hand language, like that. The human social communication was explicitly selected for the evolution, and which means the pedagogy can be applied for the human. But does it possible for the animal? To talk about that, the meerkat is a very good example. So meerkat, who lives in the desert, feed on the scorpions, but their venom is so dangerous that the baby meerkat can't eat them. So the parent meerkat teaches their young how to eat the scorpions. At first, they give the dead scorpions without any stings, but next they give a live scorpion without stings, and finally the parent meerkat gives alive and with a sting. So that kind of learning process are using only the first and second cognitive system. But in this process, they doesn't use the third process. So this is the differences between humans and animals learning process. Then we can think about how about the AI? The cognitive system is a good measure of learning potential of object. Then wouldn't it possible to evaluate the AI's intelligence by examining how well it's performing in this system? This is purely my idea, but I think it can be the good method that if this method is well designed, then it seems it can be the criteria about the evaluating training method to test like this training method are following the cognitive system like this. Right. So it was the second aspect. So let's move on to the third one. In this chapter, we want to talk about the training and teaching. So the first is training, and we call it training also to the machine learning. And machine learning is largely divided into the supervised learning and unsupervised learning. And we usually use a lot of methods like classification or regression with the RNN or CNN or a lot of that. And those kind of methods are all in the supervised learning category. So let me show what is supervised and unsupervised. So first, supervised learning receives the input from the input data and the label that correspond to correct the answer. So it says the supervised learning, it learns the model from the given data and the labels and predicts the label when the new data is received as input. But this unsupervised learning is based on the input data to find the cluster, and there's no any label to before getting answer. For example, in this figure, the supervised learning, we try to train the model to recognize a dog. But in supervised learning, it can be grouped some animals into the bird group and the rabbit group and the others. But we can name it that the first group is the dog group and second is some other group. So this is differences between the classification algorithm and the clustering algorithm. And we can think about it for the similarities between the teaching. And I divided the two parts about the teaching to academic learning and the learning from the social life. In the social life, we learn what you learn in school, same as like what you learn in school. You learn with the textbook, which is already set, and solve the test through the application of that knowledge. I think it shows the high similarities between the supervised learning, because supervised learning has also the label on each target, which is the answer of the problem. And it will be difficult to feel the differences between the comparing people which is well learned and the AI which is learned by the supervised learning, I think. But when we work on the social life, we can learn lots of things with the life of, for example, working or do exercise or something. But in that, lots of things, we don't have any correct answer. Anything will be the answer for that exercise or working. So I think this is really similar with the unsupervised learning. So being more specific, I think the supervised learning and academic learning are very similar, like quantifying and similarities between what I solved, and there's also the given answer. In the supervised learning, we quantified the accuracy with the loss function, and in real life, we can quantify with the test score. But in learning in social life and unsupervised learning, there's the similarities and differences. So I think it's a good topic to talk about it. So anyone have the idea of this, like what is similarities and differences between the unsupervised learning and the social life learning? Anyone?
Great. This is a discussion session. Yes.
Okay. Right. So I feel like learning from social life is like, for sure, it has different reward from supervised learning, in the sense that it is not clearly defined, and also I think it can be more impact, can be more long lasting. I think because, well, in supervised learning, you can redo your mistake, or you can just ignore the mistake. But from social life, if the mistake is like really really bad, it is going to be with you forever, I think. And I think social life is not in a sense, it's not an effective way to learn because of the unpredictability of those reward and punishment.
Okay, so then can I understand that the social life learning is like there's already some learning with the academic learning, and we can use that academic learning in social life, and there's an additive small learning. So I think it's a good idea. So any others idea for this?
Guys, come on.
Oh, well, then I will give some example that I think. So I think that learning in social life has some guided answer, like in social life, for example, when we make the PPT like I did, we can't do the very extreme thing like the PPT with the black screen or like that, but the training AI with the unsupervised learning, the black screen might be the cluster for the good answer, but I don't know about, yeah, but I think the real life of social learning from the social life has lots of category to clustering. So yes, picture coming.
Yeah, I agree on that, but I was wondering the difference between this parallelism, because while supervised learning and unsupervised learning generally doesn't occur together, if you do this parallelism with people, academic learning happens also while social life learning happens. So I think that the two models are influenced in some ways in people. So it's not this easily separatable. I don't know if you get what I mean. Like there are some reflections in academic learning that are then portrayed in social life for humans, at least. So I
Oh,
was wondering if you considered also this.
I agree for that. I think also the academic learning and learning with social life are not 100% divided. Yeah, I also agree for that. Yeah. Right. Then how about move on to the next.
So
So
maybe
that
can I add a comment? So maybe one difference is between learning with an objective function and learning without objective function, right? So academic learning tries to impose an objective function. Students are supposed to get high grades, so there's a quantitative measure and an objective function. And learning from social life maybe does not have really an objective function. As you said yourself, there's not really wrong or right. So it's not maybe not an objective function. Whereas in artificial intelligence, maybe there's always an objective function, try to measure the performance after the learning. So maybe the presence and absence of an objective function is one difference or similarity. And another is about the transition between learning and applying, right? So in artificial intelligence, usually there's a training phase. And then after the training is complete, the AI is exposed to kind of do its job to service, but the training then is stopped. So there's a clear separation, whereas maybe for humans, learning happens all the time and applying the learning also happens all the time. So there's not a clear separation. It's like, you know, like training on the job or learning by doing. And the school as an institution is kind of a can be regarded as a way of making a more stricter separation between learning and applying. Applying happens after school, after you graduate and you enter your job. But that's not something natural to humans. That's something that has been imposed institutionally, whereas in AIs, it's a kind of a really built into the system that there are two different modes of operation. So maybe two comments, one about the objective function and absence of an objective function, and the other separation between training, teaching, and learning, and apply on the one hand, and applying, and the absence of such a clear separation.
Okay, thank you for that. I never thought about the separation about the learning and just working. So I think it's good differences between the unsupervised or supervised between the humans. So the last aspect is what makes ethics. So there's a lot of debate about where's the morality come from. So there's two famous philosophers, the Thomas Hobbes and Immanuel Kant, which is talk about where's morality come from. The Hobbes explained the morality through this sentence: the war of all against all. So that means someone becomes immoral, then his immoral will get back to him. He will punish him because of his immoral. And Kant said the free will makes the morality. So then, how about AI? So do you think the AI can be a moral? Or before that, can we know that AI be immoral. So to talk about this, we have to talk about the trolley dilemma. So the trolley dilemma is the kind of the dilemma to talk about the utilitarianism. So basic form of this problem is when you have 5 people on the side and 1 people on other side of 2 track of train. And you have to decide which way to send the train. So when you don't hold yourself legally responsible, then you have to calculate what is ethics or what is more valuable people, where is the more valuable people in which track. But a more intuitive problem, there is a child on one trail, and another side there's a parent of that child. So you have to choose one side. Maybe it will be right to save a child for the aspects of the morality, but in the utilitarianly, it is good to save their parents because their parents will be need to grow other children. So whatever you choose, that is a good process, and the process and the result of this problem will say that you are moral. But AI can do this process. So this is from the paper of the Professor Ziegler's. So there's a 4 sentence. The first is there exists a unique right action among 2 choices, and all information is disclosed, and all action occur fully deterministically. And these 3 sentences made, oh, sorry, I will reopen. So these 3 sentences, statement, the first and second and third statements make that. Oh. Does it screen share correctly? Oh, can you see my screen now? Oh, okay. So okay. The first and second and third statements make that this problem has no logically leak. But you can see, as in the first statement, the AI can't make the answer for this problem. So be more specific about this. The question, does AI is ethical, means that we know that the AI can make an answer of the trolley dilemma above reserve. And it's kind of the halting problem, and the halting problem is undecidable. We can't know that the AI is moral or immoral. So this means that we do not know not only the AI is moral or immoral, but also we don't know the possibilities of the morality of AI. So when we look at this, I think we have to make some regulation for the AI because we don't know even AI is moral or immoral. So how do you think about this? Do we need some regulation or not? How do you think about it?
I mean, even if there is regulation, would that like actually stop a robot that would want to go rogue? Like we can create laws, we can like create a framework so like robots cannot do some things. But like if a robot really wants to do it in some ways, like supposing we have like high level AI.
So yes, as you mentioned, there's maybe some laws that robot can harm the human, or robots have to save the human if it's possible. But before that, I want to talk about the regulations for the human, that like we can't make the AI to control the weapons for the military like that. So how do you think about that?
Yeah, actually for that. So the issue is that even if we, like as a country, so let's suppose we live in the same country, let's suppose that we do not want weapons for robots. So like we want to be safe, we want, like even if a robot may be going rogue, we can, like he won't be able to like hurt people. But then like the country, like our neighborhood country will not impose those regulations. So let's say this is, for example, North Korea. Then like we're just stuck with like robots that cannot do anything against robots that can actually harm people. It's a bit like nuclear weapon, I guess. So like you don't really want it, but you actually need it because your neighbor has it.
Yeah, that's true. So
maybe global regulation would be interesting for that.
So when I saw the Ukraine war, they use a lot of drone or very new technologies to the war. But I think there's are not really developed AI to that war, I think. So I think this is the good chance to make strong regulations for the AIs become a weapon, because there was a regulation for the nuclears, as you said that before, but it was really late for the nuclear because there's already a lot of countries made the nuclear at that time. But I think there's not high developed AI for the weapon market, I think. Yeah, so that was all for my presentation. And this also. So this is my references. Yeah. And is there any question?
First of all, thank you very much. And let's take a short break now, maybe just 3 minutes to digest and give the audience an opportunity to collect their thoughts and gather some comments and questions about the content. So 3-minute break. Great. So now is the time and opportunity to give comments, to ask questions, and to conduct discussion about the content, not the quality that will be discussed later. For example, what do you think about the overall topic, pedagogy of artificial intelligence? It seems there's very little literature about this connection, but it seems also that this is a very natural connection. And so Jihoon has done a great job in emphasizing the similarities, but also the differences between pedagogy and artificial intelligence. So do you have comments about the similarities, the differences, about measuring intelligence?
I just have one comment about the regulation part. I just thought that in any way making a regulation for AI will be very hard, because the main problem is defining who should be responsible for the error. So, but then the person who made the regulation will also have the responsibility for that regulation. So first of all, it will be very hard to define the problems and like predict the problems ahead, but also like, yeah, I think trial and error here is like inevitable. Like you have to fail first to like know what's the problem, and then you can make the regulation. But then this trial and the error part could be really like devastating. So yeah, I just thought that it's very complicated and very difficult issue.
Thank you. I think that's a very good comment. Yes. So for example, when there's a car accident, right? Then there's at least 3 possible parties involved between blame or guilt and responsibilities to be shared. So first of all, there's the driver of the car. Maybe the driver has made a mistake. Then there's maybe the victim, maybe a person crossed the street without looking, without regarding for traffic signs, right? That could also share some responsibility. And then there's a car manufacturer. Maybe there was some malfunction. Maybe the brakes didn't work. Then it's not the victim nor the driver to be blamed, but the car manufacturer. And I think courts often have to deal with such questions to determine and to distribute not 100%, but to distribute percentages of responsibility, right? But now when we have automatically driving cars, then there's also the AI, the training, right? So maybe the training was insufficient. That's a fourth party that could have to share some of the responsibility. And the training is not part of the usual car manufacturing process. It's separate, right? Very good remark. Yes.
So I have a question. Considering all this complexity, in which field would you start regulating AI?
I think it will be good to start the regulations from the AI who manage the weapons, I think, because the current the well-used AI is for the car or maybe drawing the pictures with the AI like that. But I think those kind of things are not really harmful for people. Well, about the cars aspects, there will be some moral problem, but that kind of moral problem are also to the humans, and the driving car with humans and driving car with AIs have not really differences between them, but I think the weapon with the AI and weapon with the humans have big differences. The differences for the result, I think. So I think it's good to make regulation on the weapon at first. It's good.
Okay, thanks. And here, sorry, my ignorance, but then I'll have to ask you if there is someone who uses AI in weapons, because I don't know about that. Do you have an example?
Well, I heard that there's some AIs for the controlling system of the missile. I heard about it, but I think that's really simple AI, I think. Yeah.
May I add an example?
Yeah,
Right.
of
So
course.
have you heard of the robot, the dog robot, which is four-legged? I mean, it's more of robotic, but some army are trying to put gun on it. So that would be a case of trying to use AI in war. Right.
Oh, okay.
Right. And anyway, can I ask some question?
Yes, of course.
Right. So talking about the responsibility of mistake. So before we're talking about AI, let's talk about in case of human. Parents usually are responsible for a child mistake until they are, let's say, 18 in many countries, right? And at that point, the child is independent from their parents. Whatever the mistake the child make would not affect the parent legally. So will there be any point in AI such that the AI is like very independent from the creator or the trainer to the point that the mistake of AI that AI made is not responsible to the creator?
So I think that's good point. But the AI, as I mentioned on the first chapter, when the AI passed the Turing test and that AI are using for the war to harm the people, then I think that AI has their own responsibility because they have a human being when they pass the full Turing test. So in that case, I think not only for the creator, but also the AI have to follow their duty, I think.
Yes, so when a human person misbehaves or violates some ethical principle, then there's punishment, right? Punishment, maybe pedagogically speaking, previously I said that in social life, there is no objective function, but maybe there is an objective function because we all want to be happy and we want to avoid being hurt or punished. It's kind of an implicit objective function. And correction facilities like prisons use that kind of to enforce proper behavior. And regular punishment, of course, does not affect AIs. When an AI misbehaves, putting it in a prison or so is not really going to affect it, but it should somehow be really hard-coded or explicitly be able to kind of modify the objective function in order to enforce ethical behavior also in AIs in other ways than in punishment, right? And regarding the quest of AIs in military, that actually is a big sales point in modern military research, because human soldiers commit war crimes, right? So when if currently in Ukraine, for example, there's always news about some war crimes conducted by maybe only few, but by human soldiers, right? And the sales point of AI in military is that robot soldiers will not conduct war crimes and will conduct war in an ethical way, following, for example, the UN Convention of War. And that's not just theoretical consideration. Let me briefly show you a video that illustrates that. So here we go. Right, so people always say this is a search and help robot, but just imagine that North Korea would try to purchase 1,000 of these robots. Wouldn't that raise some suspicion, right? So I think the issue about regulating AIs and about artificial intelligence in military is a very urgent and pressing one. Classically, Isaac Asimov already formulated 3 laws to enforce ethical behavior of robotics, right? So first law, a robot may not injure a human being or through inaction allow a human being to come to harm. And second, a robot must obey the orders given by the human except where such orders would conflict with the first law. And third, a robot must protect its own existence as long as such protection does not conflict with the first or second law. Yes, I think Farhadiba, were you first? Okay.
Yeah, I just wanted to ask. I'm starting a little with my focus today. If you could summarize the key takeaways of your presentation once more for us.
Oh, okay, sure. Yeah. So I bring up the 4 aspects, so I think I can summarize for 4 parts. So in first part, we can measuring the intelligence for the human with IQ test or EQ test, and the Turing test for the AI, and those are not 100% accurate. I think that's the first sentence for the first part. And the second part, I can say that not so for the pedagogy, we need to follow the cognitive system, and maybe AI can follow that too, or not. We don't know about it. And in third aspect, teaching and AI training have some similarities and differences, like as we talked about in the lecture, the presentation. And in third part, we have to think about does AI can get ethics, and answer is no. Then how can we make a regulation, and where did we have to make a regulation? I think that's the fourth sentence. Yes, that's all coming. Do you have any question or comment?
My comment was regarding Asimov, because if I'm not wrong, he spent the entire career, his entire career as a writer, to explain how those laws are not as effective as they seem, right? So I'm not sure that's yeah, I understand, but maybe we can do better, because yeah, there are some conflicts, I think. And if I can quickly add on measuring intelligence, I honestly don't think that the IQ, or at least the IQ alone, is a sufficient measure for measuring. Maybe intelligence, if we define intelligence as a logical capability, but I don't think that intelligence per se has a definition yet, at least, or a complete one. Because as you correctly were pointing out, there's also emotional intelligence and other kinds of intelligence. I don't remember who was talking about 9 types of different intelligence. And well, I don't think that is exhaustive either. I don't think we quite grasp the concept of intelligence fully yet.
Yes, you're right. I also think that the IQ is not really sufficient, because even the animal can get a high IQ, but they're not target of pedagogy. So for the intelligence, I think we need more measuring stuff. Yeah.
Yes, indeed. Let me jump in here and show you 2 ways that have been proposed for measuring artificial intelligence. So the first one here, you see here, is about levels of driving automation. This has been standardized, and from level 0, which is only in emergency situations like emergency braking, right? Can you see that here? Here, automatic emergency braking, which some cars already have, right? Blind spot warning when changing lanes, right? Up to level 5, where the car is driving fully autonomously. And these different levels have been introduced and standardized. And probably these levels will also affect, well, admission of cars, right? So maybe fully automated cars will need more testing before being admitted to the road than cars that only offer emergency braking. And also maybe the insurance fees will depend on that, right? So for example, if you have a fully automatic car, then maybe the chance for conducting a driving error will, what do you think? Will it be more risky? Will the insurance fees go up if you move from a level 0 car to a level 5 car? Or do you think insurance companies will say your automatic car is driving more safely than yourself, and therefore when you switch from a level 0 car to a level 5 car, maybe your insurance fees will go down? What do you think?
I just thought about it, and I don't think the insurance company will lower the price, but will make the driver using level 0 car pay more, because when the accident happens, mostly it'll be humans' faults. If this automatic vehicle works well, then it'll mostly be humans' fault to make the accident. So I think they will cost this level 0 driver even more.
Yes, Pietro?
Yeah, I agree on that if that's the case, but how insurance right now are working is that they calculate the probability of event of having an accident. If you're reiterating and you keep having accidents, they make you pay more. because you have higher probability of making the insurance spend money. So this is the case, and you're right, only if it's proved that humans are creating more accidents than the AI.
I think it is depend on how much other vehicles are driven by AI or human. Because if our own vehicles are driving in AI, then the accident should never happen because it's our control. But always the accident should be from random reactions, which is mostly human. So I think in these days, maybe AI cars should pay more because there are so many uncertainty. But if far future, I think AI driving cars should be more cheaper.
And here's a different way of measuring intelligence of AI, namely the so-called Hofstadter test. So we talked about the Turing test, right? And when an AI passes the Turing test, it's considered maybe more intelligent than one that fails the Turing test, right? And the Hofstadter test, named after Douglas Hofstadter, is here you see. It's called Hofstadter test because it is recursive, it is self-referential, which is what Douglas Hofstadter wrote this book about, a famous book about the strange loop. An entity passes the Hofstadter test if it first creates a virtual reality, then creates a computer program within that reality, which must finally recognize itself as an entity within this virtual environment by passing the Hofstadter test. So this was proposed in 1982, and you see how it is a recursive definition. In order to pass the Hofstadter test, you have to create a virtual reality and a program within that reality that in turn must pass the Hofstadter test. So it in turn must create a virtual reality within your virtual reality, and within that virtual reality must create another computer program that pass, and so on. You see how that recursive is infinitely recursive. So that's a Hofstadter test. One way, another way of measuring artificial intelligence beyond autonomous driving. Yes, I'm happy to share the link in the chat. Thank you, Pietro. Seems we're towards reaching the end of the time and of the discussion. Jihoon, would you like to share your slides again? And maybe add some closing comments? Or not? It's fine, no problem. We've had a great discussion. This was very seminal talk and very seminal session. Thank you everybody for chiming in with your consideration and thoughts. Now I'm going to stop the recording.